In this video, we're going to learn about something super important in every computer and smartphone, something called the kernel. We'll explain what it is, what it does, and how it works in operating systems like Linux, Windows, and others. By the end of this video, you'll understand why the kernel is like the brain of your computer that you never see but always need. Please don't forget to subscribe to my channel and click on that like button if you like my video. Also click on that notification bell. Thank you. Have you ever wondered how your computer listens to your commands? Like when you click on a file, open a game, or type on your keyboard, how does it know what to do? Well, the answer is something most people don't see or talk about, but it's always working behind the scenes. It's called the kernel. You can't see it running, but without it, your computer would be a useless box. So, what exactly is the kernel? A kernel is the main part of an operating system. Think of it like the boss that tells the rest of your computer what to do. It sits between your computer's hardware, like the CPU, memory, and keyboard, and the software, like apps and games. When you click something or press a key, the software sends a message to the kernel, and the kernel talks to the hardware to make it happen. Let's take a fun example. Imagine you're playing a game. You press the spacebar to jump. The game doesn't directly control your keyboard, and instead, the game tells the kernel, "Hey, the player pressed space." The kernel then takes that information and tells the processor what to do. All of this happens in a split second. That's how powerful and fast the kernel is. The kernel is always running in the background. You never see it, but it's the one making sure everything is working smoothly. It makes sure your apps don't crash into each other, that your files are saved correctly, and that your computer doesn't overheat. It's like a traffic cop, making sure everyone follows the rules and goes in the right direction. Now let's look at how the kernel works inside different operating systems. Let's start with Linux. In Linux, the kernel is open source. That means anyone can look at its code, change it, and use it in their own projects. This is why Linux is so popular among tech lovers and developers. The Linux kernel is very powerful and runs on millions of devices, from supercomputers to your Android phone. In Linux, there's something called a monolithic kernel. That sounds like a big word, but it just means that everything the kernel needs, like memory management, file control, and device drivers, is all included in one big package. It's fast because everything is in one place, but it can also get big and complex. Now let's talk about Windows. Windows uses something called a hybrid kernel. This means it's a mix of different types of kernels. It takes parts of the monolithic style and mixes it with another style called microkernel. Microkernels are smaller and only do basic jobs, like talking to hardware. In Windows, this mix helps balance speed and stability. The Windows kernel is not open source, which means only Microsoft can see and change its code. Then we have macOS, which also uses a hybrid kernel called XNU. It's based on both microkernel and monolithic ideas. Just like Windows, it's designed to be secure and stable, which is why Macs are known for being reliable. Hey, if you want to learn more about Linux, then enroll in our complete Linux training course bundle. We also offer a free Linux course on our website. Make sure to check these out. I'm mentioning links in the description box. So why does the kernel matter so much? Because it's the part of your system that does the most important job, connecting your hardware and software. Without it, your computer wouldn't know how to save a file, open a web page, or even turn on. It also helps manage memory so that no app takes up too much space or crashes the system. Let's go deeper into what the kernel actually does. First, it manages the CPU. That's the brain of your computer. The kernel decides which app gets to use the CPU and for how long. It switches between apps so quickly that it feels like everything is running at the same time, even if it's not. Next, it handles memory management. Your computer has a limited amount of RAM, and the kernel makes sure every app gets the right amount. It also keeps apps separate so one app can't mess up another. The kernel also controls device drivers. Device drivers are tiny programs that help your computer talk to your keyboard, mouse, printer, or even your camera. Without drivers, your hardware won't work. The kernel loads and manages these drivers to keep everything working smoothly. Another big job is file system management. When you open a file or save your work, the kernel makes sure your data goes to the right place on your hard drive. It also checks that files aren't lost or broken. Then there's security. The kernel keeps your system safe by making sure apps don't do anything they shouldn't. It also stops malware and viruses from controlling your system. In Linux, the kernel can even be updated without restarting the computer. This is called live patching and is great for servers that can't afford to go offline. It's one of the reasons why Linux is used in many important places like banks, websites, and even space stations. Now you might be wondering if users can talk to the kernel directly. The answer is no, not directly. In both Linux and Windows, the kernel doesn't take instructions from users by itself. It always needs something in between to help, like a messenger. This messenger is called an interface or mediator. In Linux, the terminal is a tool that lets users type commands. These commands are handled by a program called the shell, which acts as the go-between. The shell takes your commands, translates them, and passes them to the kernel. This gives users more control because they can type low-level commands that affect how the system works. That's why people say Linux allows you to interact closer to the kernel. In Windows, the process is similar, but it's mostly hidden. Instead of typing commands in a terminal, users click on buttons or use apps. These programs send requests to the kernel behind the scenes using something called a PIs, Application Programming Interfaces. So the communication still happens, but users don't usually see or control it directly. So both Linux and Windows use a layer between the user and the kernel. Like the shell in Linux or software programs in Windows, the key difference is how much control and visibility the user has. In Linux, you can get very close to the system with commands. In Windows, the system handles most of the technical stuff for you. You might also hear people talk about kernel panic. This is when something goes wrong in the kernel and the whole system crashes. It's like when the brain of the computer gets confused and doesn't know what to do. It's rare, but it can happen if there's a bug or a hardware problem. The kernel is also what makes some operating systems faster than others. A well-designed kernel makes your computer quick and responsive. A badly designed one can make it slow and buggy. That's why tech companies spend so much time testing and improving their kernels. Some systems even let you choose your own kernel. In Linux, you can pick a kernel that's fast, secure, or perfect for gaming. This is why tech experts love Linux, because they get full control. To sum it all up, the kernel is the heart and brain of your computer's operating system. It connects the software with the hardware, manages memory, handles files, controls devices, and keeps your system safe. Whether you use Linux, Windows, or macOS, the kernel is always there, working behind the scenes to make everything run smoothly. And now that you know what a kernel is, you have taken your first step into understanding how computers really work. It's not magic, it's smart engineering. Keep exploring and you'll discover even more about the invisible parts that power your digital world. I'll see you in the next video, and let's keep learning together.